Right now, 2,000 miles beneath your feet, there's a river of molten iron the size of the moon. It's spinning, it's churning. And it is the only reason you're alive to hear this sentence. That river makes a shield, invisible, silent, wrapped around the whole planet. And it has never once, in your lifetime, given you a reason to think about it. You've never seen it. You've never felt it. You just trust it's there. The way you trust the floor will hold when you get out of bed. Here's the part nobody tells you. That shield isn't fixed. It isn't a law of nature carved once and left alone. It's the output of a machine, a violent, unstable, ever-shifting machine. And 41,000 years ago, that machine sputtered. Not metaphorically, not weakened a little, nothing to see here. The compass, if you'd had one, would have stopped pointing anywhere close to north. And it didn't happen for an afternoon. It didn't happen for a season. It happened for the better part of 1,000 years. While people very much like you and me were alive underneath that failing sky, with no idea why the world suddenly felt different. I want to tell you how we know this. Because the proof isn't a rumor and it isn't a legend passed down around a fire. It's sitting in a swamp in New Zealand, buried in mud, wrapped in the bark of a single ancient tree. And it's sitting in ice on opposite ends of the earth, agreeing with itself down to a level of precision that should honestly unsettle you a little. But I also want to be straight with you about something else, right up front. Because this is where the story gets complicated, and complicated is where it gets interesting. Some scientists looked at this 1,000-year failure of Earth's shield and said, this nearly ended us. Ozone gone thin, radiation pouring down, extinctions, a crisis written into the bones of the Ice Age. Other scientists, just as serious, just as careful, looked at the exact same data and said, slow down, that argument is still going. It was going in the pages of one of the most respected science journals on Earth in 2021. And as far as I can tell, it hasn't been settled. I'm not going to pretend it has for either side, because pretending would be a lie, and the true version of this story is stranger than the tidy one anyway. So here's where we're going. I'm going to take you into a swamp, and then into a French volcano field, and then into two sheets of ice 15,000 kilometers apart. And I'm going to show you how scientists reconstructed a 1,000-year catastrophe that left behind no crater, no ash layer, no ruins, nothing a person walking past would ever have noticed. Just a tree, quietly keeping score. And by the end, I want you to feel something you probably haven't felt about a compass before, because it turns out that little needle isn't reading a fact about the universe. It's reading a weather report from 2,000 miles down, and the forecast has already failed once. The book that actually sent me chasing this, or rather, the paper, because this rabbit hole starts with a single scientific paper that made headlines it's still trying to live down, is called A Global Environmental Crisis 42,000 Years Ago. It came out in February 2021 in the journal Science from a research team led by a geneticist named Alan Cooper and a scientist named Chris Turney. And I want to say clearly, before we go any further, I don't think everything in that paper survived contact with the rest of the scientific community. Some of its boldest claims got pushed back on, hard, by other serious researchers. I'm going to show you both sides. That's not me hedging. That's the actual honest state of the science, and I think you deserve the real version, not the clickbait version. But underneath the argument, underneath the controversy, there's a core of this story that nobody disputes. Nobody. Not the authors, not their critics, not a single geophysicist who's looked at the data. The magnetic field really did fail. The poles really did wander. This really happened on this planet roughly 41,000 years ago, and it lasted roughly 1,000 years. That part is not up for debate. What it did to life on the ground, that's the fight. And I think the fight itself is going to teach you something almost as important as the discovery. Let's start with the tree. Picture a swamp, not a postcard swamp, a working, muddy, unglamorous wetland near a place called Ngawa up in Northland, New Zealand. Excavators are out there, moving earth, doing the kind of infrastructure work that happens in wetlands all over the world. And then a machine pulls something out of the mud that stops the whole job. A log. Not a normal log. A slab of ancient kauri wood, over 2.5 meters across, wider than most of us are tall lying down, more than twice as wide as your outstretched arms could reach. It's been sitting in that anaerobic mud, sealed away from oxygen and decay for more than 40,000 years. And the bark is still on it. Think about that for a second. 40,000 years, and the bark hasn't rotted away. The tree that grew that bark died before your species had invented the wheel, before agriculture, before cities, and it still has its skin. Researchers at the University of Waikato get their hands on cross-sections of this thing. And here's where it turns from a striking artifact into a scientific instrument. A tree doesn't just grow, it counts. Every single year, it lays down one more ring, a permanent dated record of the atmosphere it breathed that season. This particular kauri had 40 of those rings. 40 years of testimony, one ring at a time, and every ring can be radiocarbon dated in sequence, so researchers aren't just estimating when this tree lived. They're reading it almost like a calendar, year by year. And when they read what's locked inside those rings, they find something violent. A massive spike in atmospheric carbon-14, not a gentle drift. A spike, the kind of signal you don't get from ordinary yearly variation. Something happened to the sky itself, during the exact centuries this tree was alive, and the tree recorded it, whether or not anyone was there to notice. Here's the thing I can't get over. Nobody built this record on purpose. No observatory logged it. No person stood outside and wrote down what they were seeing. A tree, a living thing, standing in a swamp, doing nothing more dramatic than photosynthesizing, became the courtroom stenographer for a planetary event 40,000 years before anyone would think to ask the question. But a tree ring, on its own, is only half a story. Carbon-14 turning up in one log in one swamp in New Zealand could, in theory, be a local fluke, something about that particular patch of ground, that particular year. Real science doesn't trust a single witness, it wants a second one, ideally one that couldn't possibly have talked to the first. So let's go get the second witness, and to do that we need to go back further than the swamp, all the way back to 1967, and a stretch of dormant volcanoes in the middle of France. In the Chaîne des Puys, a chain of dormant volcanic hills in the Massif Central, there's cooled lava that hasn't erupted in thousands of years. The Lachamp and Olby flows, hardened rock sitting quietly in the French countryside. And rock like that keeps its own kind of diary. When lava cools, the iron-rich minerals inside it freeze into alignment with whatever the magnetic field is doing at that exact moment. It's like a compass needle getting set in concrete. Once it hardens, that direction is locked in forever. In 1967, two researchers, Bonhomet and Babkin, took a look at what direction was locked into this particular French rock. And it wasn't north, it wasn't even close to north. The magnetization pointed nearly opposite the way a compass points today. As if, for the moment this lava froze, the entire planet's sense of direction had come loose. At the time, this was genuinely strange. Scientists already knew Earth's field could fully reverse over geological time, north becoming south, over hundreds of thousands of years, the compass slowly flipping. But this was different. This wasn't a slow, permanent flip. The rock above and below this layer still pointed the normal way. Whatever had happened here was temporary, a stumble, not a fall. Geophysicists would later give this kind of event its own name, an excursion, not a full reversal, a failed one. The field lurching toward flipping, losing its grip, and then, eventually, finding its way back. So now hold those two pieces side by side in your head. A tree in a New Zealand swamp, recording a violent spike in the sky's chemistry. A frozen splash of French lava, recording a compass that had lost its mind. Different continents, different kinds of rock and wood. Different research teams decades apart who weren't even trying to answer the same question. And when scientists eventually dated the French lava properly, using radioactive decay in the rock itself, methods refined over decades to get more and more precise, the number that came back sat right in the same window as the tree. Somewhere around 40,000 years ago, not close, not roughly the same era, the same event. That's when this stops being two unrelated oddities and starts being one story. But even that wasn't enough for scientists to feel sure. Because here's the uncomfortable truth about doing this kind of detective work across tens of thousands of years. Coincidence is cheap. Two things happening in the same rough century on two different continents could still be an accident of timing. If you want to prove a planet-wide event, you need a witness that couldn't have been fooled by anything local. You need two locations so far apart, so physically disconnected, that there's no ordinary explanation for them agreeing, except that something happened to the entire Earth at once. So picture the two most remote opposite places you can put a research station: Greenland, near the top of the world, and on the very bottom of the planet, the ice sheets of Antarctica. Sites like Dome Sea and Vostok, thousands of miles apart, different hemispheres, different weather systems, different oceans between them. Both of those places have something in common, though. They're covered in ice that has been quietly falling, layer by layer, for tens of thousands of years without melting. Which means, like the tree, like the rock, the ice is also keeping a diary written one snowfall at a time, sealed in place before the next snow buries it. In 2007, a researcher named Reisbeck, working with ice cores pulled from both ends of the Earth, went looking for a particular signature buried in the frozen record, a rare cosmogenic isotope called beryllium-10. And here's why that isotope matters, and this is the piece that ties the whole mechanism together. Beryllium-10 isn't made in the ground, and it isn't made in the ocean. It's made in the sky, when high-energy cosmic rays, streaming in from deep space, slam into the upper atmosphere and shatter atoms of nitrogen and oxygen. Ordinarily, Earth's magnetic field deflects a huge share of those cosmic rays before they ever get that deep. But when the field weakens, the gate opens wider. More cosmic rays get through, more collisions happen, more beryllium-10 rains down and gets locked into the falling snow. So if the magnetic field really did fail all across the planet around 41,000 years ago, you'd expect to see a spike in beryllium-10, not just in one ice core, but in both, on opposite ends of the Earth, at the same moment in the layered record. That's exactly what Reisbeck found. A synchronized spike, Greenland and Antarctica agreeing with each other to a level of precision that later work would sharpen down to about 20 years. 20 years out of an event that happened 41,000 years ago. That's like locating a single afternoon inside 4 centuries. Sit with that for a second, because I think it's the most quietly stunning part of this whole case. Two ice sheets on opposite sides of a 15,000-kilometer planet, never in contact with each other, independently recording the exact same interruption in the sky. It's like two witnesses on opposite sides of a courtroom, separated the entire time, giving the same account down to the hour. When that happens, a jury doesn't call it coincidence, they call it proof. And now, we have 3 separate lines of evidence from 3 completely different kinds of material, gathered by 3 completely different research efforts: the tree in New Zealand, the lava in France, the ice at both poles, and every single one of them is pointing at the same narrow window of time. The magnetic shield around this planet did not merely dip. It faltered, badly, for a very long stretch of time, and it left its signature in wood, in stone, and in frozen sky, whether or not there was a single human alive who understood what they were looking at. Which raises the obvious question. If the shield really did come down for the better part of 1,000 years, not a blink, not a season, but a span longer than the distance between you and a medieval castle, what was actually happening to the field itself while that was going on? Because it got weaker is the easy version. The real version is stranger than that. Here's what almost nobody pictures correctly when they hear the magnetic field weakened. They imagine a dimmer switch turning down evenly, the same 2 poles, just fainter. That's not what the evidence shows. Deep beneath your feet, the field isn't generated by anything as tidy as a bar magnet. It's generated by the geodynamo, a churn of liquid iron and nickel in Earth's outer core, thousands of kilometers down, driven by heat rising, by the planet's own spin, twisting that molten metal into moving currents of electric charge. Moving charge makes a magnetic field. That's the whole engine. And an engine made of churning liquid metal isn't a fixed machine stamped out once and left alone. It's closer to weather, chaotic, fluid, never quite the same shape twice, even though on average, over centuries, It settles into something that looks like a clean two-pole magnet with a north and a south. During the collapse, that average broke down. The clean, simple, two-pole shape you'd draw on a diagram, the shape a compass depends on, came apart. Instead of one steady north and one steady south, the field's geometry scrambled into something messier. Multiple weak poles at once, popping up and fading, none of them holding position. Imagine a compass needle that doesn't just get sluggish. It starts to wander the room, point it anywhere, wait a while, point it somewhere else, not because the needle is broken, but because there's no longer one clear north out there, strong enough to grab it and hold it. And the strength behind all of this didn't just dip modestly. At its weakest point during the transition, the field fell to as little as around 5% of the strength it has today. A small fraction of the shield you're standing under right now, gone. Even during the reversed, unsettled phase that followed, it hovered around only about a quarter of today's strength. I want to be honest about these numbers, because different studies land on slightly different figures for exactly how low and exactly how long. This is genuinely a case where the broad picture is rock solid and the precise decimal points are still being argued over. But the broad picture is enough on its own. For a very long stretch of time, this planet's shield was operating at a small fraction of its normal output. The whole failure, start to finish, the field sliding out of its normal shape, sitting weak and scrambled and slowly finding its way back to something like normal, took on the order of a few hundred years for the transition itself, with the weak reversed phase lingering roughly another few hundred years on top of that. Add it up depending on exactly where you draw the start and end line, and you get an event stretching towards something close to 1,000 years. Not a flicker, not a season. Something closer to the entire span between now and the founding of a medieval kingdom, lived out entirely underneath a sky with its shield down. And here's the detail that I think deserves to sit with you for a second, because it's easy to say the field was weak and let that stay abstract. A weaker field doesn't just mean a less reliable compass. Remember what that field actually does every single day, right now, without you ever noticing it working. It deflects the charged particles streaming off the sun, and it deflects a good share of the cosmic radiation arriving from deep space before either one ever reaches you. That's not decoration. That's the job. So when the field drops to a fraction of its strength, and its shape stops being one clean, organized barrier and becomes a scrambled mess of weak, wandering poles, the question stops being, would a compass have worked? The question becomes, what was actually getting through into the upper atmosphere, above the heads of everyone alive on Earth at the time? That's the exact question Alan Cooper and Chris Turney's team tried to answer in 2021, and it's the question that split the scientific community right down the middle. Here's where the mechanism gets specific, because radiation got through is too vague to mean anything on its own. The field itself doesn't block ultraviolet light. That's a common mix-up, and it's worth clearing up properly. What blocks ultraviolet light is ozone, high in the atmosphere, a thin, fragile layer of oxygen molecules rearranged into a form that happens to absorb the exact wavelengths of sunlight that damage living tissue. The magnetic field's job is different. It's the gatekeeper for cosmic rays and solar particles. And Cooper and Turney's argument was that those incoming particles, no longer being turned away, could themselves disturb the chemistry of the upper atmosphere, including, they proposed, the chemistry that keeps that ozone layer intact. So picture it as two separate machines stacked on top of each other. One machine, the magnetic field, decides how much high-energy radiation is even allowed to reach the upper air. The second machine, atmospheric chemistry, uses ordinary sunlight to keep manufacturing the ozone that blocks the most dangerous UV from reaching the ground. The field doesn't hand you sunscreen directly. The argument is that it runs the factory that makes the ingredients for it. Weaken the field enough, disturb the factory enough, and what leaks through isn't the field's radiation directly. It's more ultraviolet light, reaching further down than it should, because the factory upstairs stopped running at full capacity. Cooper and Turney didn't stop at the magnetic field alone either. Their model stacked a second condition on top of it, something called a grand solar minimum, an extended stretch of unusually low activity from the sun itself, layered on top of the weak Earth field. Two rare conditions happening at once, and their claim was that this combination, a gate wide open and unusual behavior from the very source pouring through it, was what tipped the scale from unsettling to catastrophic. From there, the paper reached further than the ice and the tree alone could carry it. They proposed that this stacked crisis was severe enough to leave marks across the living world of that era. Shifts in atmospheric circulation, a chain of ecological stress, and they linked it to things far beyond ozone chemistry. A wave of megafaunal extinctions, a decline in Neanderthal populations, and a global uptick in behaviors like sheltering in caves and using red ochre pigment, as if life on the surface had gotten measurably more dangerous. They even gave the proposed event a name of its own, the Adams Event, a nod to Douglas Adams and the number 42, since their date for the crisis landed right around 42,000 years ago. It's a clever name. It's also, worth saying plainly, not an accepted term outside their own paper. It's a label one research group gave their own interpretation, not something the wider field of geophysics has adopted as settled fact. And I want to slow down on that word interpretation, because this is exactly the point where the story stops being a simple chain of proof and becomes something messier and, honestly, more interesting. The reaction from other scientists was fast, and it was pointed. A formal response was published in the very same journal, Science, later in 2021. A comment, as it's called in academic publishing, meaning a direct peer-reviewed challenge to the original paper's conclusions. One of the researchers behind it, an archaeologist named Hofecker, along with colleagues, went straight at the heart of the catastrophe claim. Their argument wasn't that the magnetic field hadn't weakened. Nobody was disputing that anymore. The ice and the tree had settled it. Their argument was about what came next in the chain of reasoning. They pointed out that when you actually ran the climate modeling carefully, the effects on ozone and surface climate came out, in their words, nuanced and subtle, smaller in fact than the ordinary swings in climate that the Ice Age was already producing on its own, swings you can see plainly recorded in the very same ice cores. In other words, even if you accept every piece of the mechanism, the disturbance it produces looks modest next to the background noise nature was already making. There was more. An anthropologist named John Hawkes looked specifically at the genetic evidence Cooper and Turney had leaned on to tie the event to population bottlenecks. The idea that human and Neanderthal populations had been squeezed down hard around this exact date, leaving a mark in the DNA of their descendants. Hawkes's read of that same genetic literature was that it didn't actually line up cleanly with a single synchronized event at 42,000 years ago at all. The dates were fuzzier, messier, less coordinated than the catastrophe story needed them to be. And then there's a scientist named Gavin Schmidt, a climate researcher who wrote an independent technical breakdown of the paper on a site called Real Climate, and his critique cut at something structural in how the original study had been built. To get a detectable signal out of their model at all, the researchers had needed to stack two extreme conditions together: the deepest part of the magnetic minimum and an unusually severe solar minimum, both hitting at the same time. Schmidt's point was that this is a big assumption to lean an entire global crisis narrative on. Nature doesn't owe you a tidy coincidence where its two rarest conditions line up perfectly just to make your hypothesis work. Cooper and Turney didn't stay quiet. They published their own formal response, defending the timing, defending the synchrony between their kauri record and the broader picture. That back and forth, comment, then response, both peer-reviewed, both sitting permanently in the scientific record, is, I think, one of the most honest things you'll ever see in published science. It's not a scandal. It's not one side being caught lying. It's two groups of serious, careful researchers looking at the same beryllium, the same carbon, the same ice, and disagreeing about how far the story is allowed to travel from proven fact into inference. There's one more piece of evidence the skeptics raised, and it might be the most persuasive one of all, because it doesn't require trusting anyone's model. It just requires comparing this event to another one like it. Roughly 125,000 years ago, There was another geomagnetic excursion known as the Blake excursion. By some measures, its weakening of the field was comparable to Lachamp. In some respects, it lasted even longer. And yet, when researchers look for a matching pulse of extinction, a matching cultural shift, a matching crisis in the fossil and archaeological record around 125,000 years ago, it isn't there. No parallel wave of die-offs, no parallel spike in cave-dwelling or ochre use. The shield came down, by some measures, for even longer than it did at Lachamp, and the world, as far as anyone can tell, kept going without a comparable catastrophe. That's the control case the skeptics point to. If a weak magnetic field reliably drags a crisis behind it, where's the crisis the last time this happened just as badly? And if it isn't there, what does that tell you about how much weight the field's failure alone can actually carry? I don't think that question has a clean answer yet. I don't think anyone does. What I can tell you honestly is where the solid ground actually ends. The shield failing, proven 3 times over, in wood, in stone, in ice. The ozone chemistry connecting a weak field to more ultraviolet light reaching the ground. An established mechanism, the actual chemistry is real and understood. Whether that mechanism, in this specific case, was strong enough to reshape the Ice Age world, push species toward extinction, and change how Neanderthals and early humans lived, that is a live argument being fought out by serious people, and it has not been settled in either direction. I'd rather tell you that plainly than pretend one side has already won, because pretending would be the more comfortable story and the less true one. Here's what I keep coming back to, though, and it's the detail that turns this from ancient history into something uncomfortably present tense. This isn't a machine that broke once 41,000 years ago and has sat perfectly calm ever since. It's measurably moving right now in your lifetime, tracked by satellites in orbit above you as you sit here listening to this. Since the field's strength has been directly measured over roughly the last 2 centuries, it has dropped by about 9% globally. 9% doesn't sound dramatic on its own, said quickly, but hold it next to what you just heard about Lachamp, a collapse to a small fraction of normal strength over the span of a few hundred years. 9% in 200 years isn't nothing. It's a rate. And a rate is a direction, not a fixed number sitting still. There's a specific place on Earth where you can watch this happening most clearly, and it isn't hidden in a lab. It's a real patch of sky and space that engineers have to actively plan around today. It's called the South Atlantic Anomaly, a broad region stretching roughly over South America and out across the South Atlantic Ocean, where the magnetic field is measurably, significantly weaker than the global average. Satellites that pass through it experience more radiation exposure than they do anywhere else in low orbit. It's a known hazard spacecraft operators design around it. Some instruments are powered down while passing through to protect their electronics from the extra particle bombardment. It is, quite literally, a hole in the shield that engineers have to steer their machines around today, the same way you'd steer around a pothole you know is coming. And it's not sitting still either. A European satellite mission called SWARM, which has been mapping Earth's magnetic field from orbit with extraordinary precision, has tracked this weak patch expanding, growing by roughly 0.9% since 2014 alone. Let that sit for a second. Not since Lachamp, not over some geological span too slow to matter to a human life, since 2014. Within the span of a single decade, a satellite in orbit measured this weak spot getting bigger. Now, I want to be careful here, the same way the scientists tracking this are careful, because this is exactly the kind of fact that's easy to run away with. Nobody at the European Space Agency, nobody who works on the SWARM mission, is standing up and saying this proves a reversal is imminent, or that we're heading toward another Lachamp-style collapse on any predictable timeline. That claim isn't in the data. What is in the data is simpler and honestly stranger for being simpler. The shield above you is not a fixed structure. It is being measured continuously, changing shape, weakening in specific places and growing in others, on a timescale you could watch unfold across your own adult life if you wanted to. Think about what that actually means, set against everything you just heard about Lachamp. The engine that failed 41,000 years ago never stopped running. It never got fixed, in the sense of being repaired once and locked into place. It simply recovered, the way weather clears after a storm, and it has kept doing exactly what it was doing before the storm, and during the storm, and after it. Shifting, never quite settling, never holding one configuration for very long by the standards of a planet that's been doing this for billions of years. That's the thing that I think gets lost when this story gets told as a single ancient event with a beginning, middle, and end. It isn't a chapter that closed. It's a process that is still running right now underneath the ground you're standing on, and the compass needle in your pocket, if you own one, is pointing wherever it's pointing today only because that process happens, this century, to be behaving itself reasonably well. And once you see it that way, once you stop thinking of the magnetic field as a fact about the planet and start thinking of it as an output, a reading, a live measurement of something churning and unpredictable 2,000 miles beneath you, you start noticing the same shape showing up again and again at every scale of this story if you know where to look. Because the same instability doesn't just live in the core, it's threaded through every layer of this story if you trace it carefully, and once you see the pattern, you can't stop seeing it. Start at the bottom, where we already spent the most time, the geodynamo itself, that churn of liquid iron and nickel 2,000 miles down. It was never a fixed object. Even in the calmest, most stable centuries of Earth's history, it was never actually still. It was always closer to weather than to architecture, currents rising, twisting, canceling each other out in places, reinforcing each other in others, producing a field that only looks steady because you're standing on a timescale too short and too calm to notice the churn underneath it. Lachamp wasn't the machine breaking. It was the machine's ordinary turbulence, tipping further than usual, for longer than usual. Now move up one level to the shape the field actually took while it was struggling. Those multiple weak wandering poles instead of one clean north and south. That's the same instability, just showing a different face. A system that's supposed to organize itself into one dominant pattern instead fractured into several competing temporary ones, none strong enough to win outright, all of them shifting until eventually, after centuries, one configuration finally won out again and the field snapped back toward its familiar two-pole shape. Weather in the core produces weather in the field's very geometry. The instability doesn't stay contained at its source. It propagates upward into the shape of the thing the source produces. Move up again to right now, to the South Atlantic anomaly stretching across the sky above South America and the ocean beyond it. That's the exact same pattern at a completely different scale and a completely different moment in time. A system that looks orderly from a distance, a smooth, symmetrical shield wrapped around a planet, and turns out, the moment you actually measure it closely with a satellite, to have soft spots, places where the churn beneath is producing a locally weaker output. It's not a different phenomenon happening today than the one that happened 41,000 years ago. It's the same restless machine at a different point in its endless, uneven output, producing a small regional echo of the exact kind of weakness that once, briefly, swallowed the whole planet at once. And then there's the one layer of this story that surprised me the most, because I didn't expect to find the same pattern sitting inside the argument between scientists themselves, but it's there. For most of the 20th century, the general public's picture of the magnetic field was about as settled as a fact can get. North is north. The compass works. It's a fixed feature of the world, like gravity, like the length of a day. That picture held up fine, right up until researchers actually went looking closely. Into French lava, into ice at both poles, into a tree in a New Zealand swamp, and discovered that underneath the calm surface picture, there was a documented history of near-total failure. The consensus wasn't wrong, exactly. It was just standing on top of a much less settled reality than anyone realized, the same way the field's calm two-pole average sits on top of a churning, unpredictable core. And even now, having found that the scientists studying it can't fully agree on what it means, Cooper and Turney seeing a global crisis, Hofecker and Schmidt and Hawkes seeing a real event with an overstated aftermath, the Blake excursion sitting there in the record as a stubborn counterexample that refuses to resolve the argument either way. That disagreement isn't a failure of science. It's the same pattern showing up one level higher still, a system that looks settled from far away, a solved corner of geophysics, turning out, the moment you actually lean on it, to be exactly as unresolved and turbulent as the molten iron the whole argument is about. Nothing in this entire chain was ever actually as fixed as it looked from a comfortable distance. Not the core, not the poles, not the shield above your head, not even our own certainty about what that shield has done to the living things standing underneath it. Zoom out far enough and the wobble is the constant. The stillness is the illusion, the thing you only see if you're not looking closely enough or not waiting long enough to catch it moving. And once you accept that, once you actually let it sink in that the calm you've always taken for granted is a temporary truce, not a rule. It stops being a fact about rocks and satellites and ice cores. It starts being a fact about you, standing exactly where you are, right now, reading these words under a sky that has already, once, let you down. Try for a moment to actually feel the scale of what you're standing on. Not think about it abstractly. Feel it. 2,000 miles of solid rock beneath your shoes, and beneath that, a layer of molten metal roughly the size of Mars, spinning, dragging, generating an electric current purely because it happens to be moving the way it's moving, at the temperature it's at the pressure it's under. Nobody built that. Nobody tuned it. It assembled itself out of the raw physics of a forming planet billions of years ago, and it has been running unattended ever since. The longest uninterrupted machine you will ever depend on, and the one you have thought about the least. You've spent your entire life under its output without a single conscious thought about it. Not once walking to work, sitting in traffic, lying awake at 3 in the morning. Did you think? Right now, that field is doing its job. It doesn't ask for maintenance, it doesn't send a warning light, it just works silently, and because it has always simply worked, within the scope of every human life ever lived, we built an entire unconscious assumption on top of it. The assumption that the sky above us is a fixed, finished, permanent thing. Solid, reliable, done. But you now know that isn't true. You know there was a stretch of time, not a geological eye blink measured in millions of years, but a stretch nearly as long as the distance between now and the fall of Rome, when that assumption would have been wrong. When the shield above the heads of people who looked essentially like you, who loved and feared and raised children essentially the way you do, was running at a fraction of its strength, its geometry scrambled, its protection thinned out for the better part of 1,000 years. And not one of them knew it. There was no instrument to read, no satellite overhead, no scientist to explain what was happening to the sky. Whatever they felt, if they felt anything at all, they had to live through without an explanation, the way you'd live through an illness with no name. That's the part that actually gets me, more than the cosmic rays, more than the beryllium, more than the ozone chemistry. It's the sheer silent invisibility of the whole thing. A crisis with no crater, no fire, no sound. If it did what its boldest interpreters think it did, it was a catastrophe that never announced itself. No thunderclap, no falling sky, nothing dramatic enough for a person standing outside to point at and say, "There, that's what's wrong." Just, maybe, slightly harsher sun. Maybe more people getting sick in ways nobody could explain. Maybe animals behaving strangely for reasons nobody could trace back to a cause 2,000 miles underground. A disaster, if it was one, that could only be diagnosed 41,000 years later by a tree that happened to survive in a swamp. And here's where I have to turn this back on you, because that's really what this whole chain of tree rings and lava and ice has been building toward. You are not living after that machine got fixed. You are living during its next stretch of ordinary operation. And ordinary for this machine has already been shown to include total or near total failure. Not might include it, hypothetically, the way any system could theoretically break in some distant discounted future. Has already included it, within the lifespan of anatomically modern humans. Within a span of time that, on a geological clock, barely registers as a tick, 9% over 2 centuries, a weak patch over the South Atlantic, growing, watched from orbit in real time within the last 10 years. I'm not telling you that adds up to a countdown. Nobody credible is claiming that, and I already told you why the honest answer is that we don't know what it adds up to. But I am telling you that the number is moving in a direction while you are alive to watch it move on instruments precise enough to catch a change smaller than a single percentage point in a single decade. That's not ancient history anymore. That's a live reading taken this week on a machine with a documented history of nearly going quiet. Here's the strangest part, the part that I think turns this from an unsettling fact into something closer to a kind of vertigo if you actually let it land. Everything about your daily experience of solidity, the ground that doesn't move, the sky that doesn't change, the compass that always finds north, all of it is downstream of a process that has no interest in being solid. Rock feels permanent because you experience it across a human lifetime, a few decades, a blink against the timescale it actually operates on. The magnetic field feels like a law because it has, for your entire life, and your parents' lives and their parents' lives, stretching back further than written history, simply held its shape well enough that nobody needed to question it. But permanence on this planet has never actually meant unchanging. It has only ever meant hasn't changed yet on the timescale you happen to be watching it. You are not standing on solid, finished ground under a fixed and finished sky. You are standing for one brief and ordinary moment on top of a slow, churning, unfinished process, one that occasionally, without asking permission, without sending a warning, lets its guard down for 1,000 years at a time. The only reason that feels like new information instead of a fact you already knew is that the last time it happened, there was no one alive who could measure it. This time, there is. Picture, for a moment, and I want to be careful here, because this next image sits inside the contested half of the story, not the proven half, what the Cooper and Turney team imagined was happening on the ground during those centuries. Somewhere in Ice Age Europe, a group of people retreat deeper into a cave than they might have in an ordinary year. Somewhere else, someone works red ochre pigment into a mixture and presses it onto a hand, onto a wall, onto their own skin. Across the fossil and archaeological record of this general period, researchers have documented an increase in exactly these behaviors: more cave use, more ochre, and the boldest version of this story asks you to connect that pattern to the sky itself. Ochre, some researchers have proposed, may have functioned as a crude form of sun protection, a mineral pigment smeared onto skin that happened to have UV-absorbing properties. Caves, obviously, block the sky entirely. I want to be exactly as careful with this image as the scientists arguing about it have had to be. This connection, sky failing, danger rising, behavior shifting in response, is the interpretation, not the established fact. The increase in cave use in ochre is real, documented in the archaeological record. Whether it happened because of the magnetic field's failure, or for a dozen other reasons that had nothing to do with the sky at all, cultural shifts, population movements, changes in climate that were already underway for entirely separate reasons, is precisely the piece that Hofecker and Hawkes and Schmidt pushed back on. It's a genuinely seductive image, a group of ancient people instinctively sheltering from a danger they couldn't see or name. I find it seductive too, but seductive isn't the same as proven, and I'd rather hand you the honest, unresolved version of that scene than a tidier one that the evidence doesn't actually support yet. What is worth sitting with, regardless of which side of that argument turns out to be right, is just how strange it is that the question is even askable. 41,000 years is long enough that almost nothing survives to be examined directly. Bodies decompose, wood rots. Memory obviously carries nothing across a gap that size. And yet here we are, close enough to the actual texture of that era to argue seriously about whether a specific mineral pigment used by specific people in a specific pattern might trace back to a specific failure in the sky above them. That level of resolution, reaching back that far, genuinely didn't exist a generation ago. It exists now because a tree happened to survive in a swamp, and because ice happened to keep falling at both poles without ever melting, and because a piece of French lava happened to freeze at exactly the wrong or right moment. There's another thread worth pulling on here, one that connects the megafaunal extinctions to the same argument, and it's worth being precise about what megafauna even means in this context, because the word can sound abstract until you picture what it actually refers to. Around the world, in the tens of thousands of years spanning the end of the Ice Age, a wave of enormous animals disappeared, species that had thrived for hundreds of thousands of years before that, vanishing within a relatively narrow window. Cooper and Turney's original paper placed part of that extinction wave alongside their proposed environmental crisis, suggesting the same weakened shield, the same disrupted atmosphere, might have stressed ecosystems already under pressure from a changing climate, tipping already struggling populations over the edge. The counter-argument, again, isn't that these extinctions didn't happen. They plainly did. That part isn't in dispute by anyone. The counter-argument is about timing and cause. Climate was already shifting dramatically across this whole period for reasons that have nothing to do with the magnetic field at all. Ordinary, well-documented ice age variability, the kind visible directly in the very same ice cores used to date the Lachamp event, showing swings in temperature and precipitation that dwarf anything the modeled ozone and radiation effects could plausibly add on top. If a species was already being squeezed by a shifting climate, a shrinking habitat, a changing food supply, how much of the final push, if any, can honestly be attributed to a weakened magnetic field specifically, rather than to the larger climate forces already in motion around it? That's the actual shape of the disagreement, underneath the more dramatic headline version of Earth's shield failed and wildlife paid the price. It's not a clean yes or no. It's a question of how much weight one factor can bear when it's tangled up with several much larger ones happening at the same time. I think that tangle is honestly the most realistic picture of how ancient catastrophes actually work, if they happen at all, not a single dramatic cause with a single dramatic effect, but a stack of stresses arriving at once, each one ordinary enough on its own, the combination of all of them together being what actually decides whether a population survives or doesn't. A weakened magnetic field, a grand solar minimum, an already shifting ice age climate, any one of those alone might have been survivable. Whether all three together crossed some invisible threshold for some species in some specific place is a question that may never have a clean answer, because the evidence that would settle it decayed and scattered tens of thousands of years before anyone thought to look for it. There's a quieter piece of this story that rarely makes it into the headline version, and it's worth giving it its own moment because it's where the abstract argument turns into something you can actually picture happening at a desk on a specific afternoon to a specific person. Dating an event like this precisely enough to argue about it at all is its own kind of achievement, one that's easy to skip past. The rock in France had to be dated using the slow, steady decay of radioactive potassium into argon gas, locked inside volcanic minerals the moment they cooled, a clock that ticks reliably enough to read across tens of thousands of years, but coarse enough that early measurements could only place the event within a wide window. Over decades, as the techniques were refined, more sensitive instruments, better calibration, methods measuring not just potassium and argon, but also uranium, decaying into thorium in different mineral samples, that window narrowed. What once might have been, somewhere around 40,000 years ago, give or take a few thousand, tightened, generation of researchers by generation of researchers, into the far more precise figure scientists work with now. Roughly 40.7 thousand years ago, with an uncertainty of well under 1,000 years either direction. That narrowing isn't a footnote. It's the difference between a vague rumor and a datable event you can cross-check against a tree ring and an ice layer and expect them to actually agree. And they did agree, which is the part worth sitting with one more time from a different angle. 3 independent clocks, radioactive decay in cooled lava, annual growth rings in a living tree, and layered snowfall compressed into ice at opposite ends of the planet. Three completely different physical processes, none of which were designed with each other in mind, none of which could have been faked or coordinated across 41,000 years, converging on the same narrow window. That's not the kind of agreement you get by accident. That's the kind of agreement that ends an argument about whether something happened, even while it opens a much longer argument about what it meant. I mentioned earlier that this whole channel exists because ideas like this one are the ones I can't stop turning over after I close the laptop. And if a slow-burning, ground-shifting rabbit hole like this one is your kind of thing, this is exactly the kind of story I keep digging into here, so it's worth hitting subscribe and coming back for the next one. Back on the ground, or rather 2,000 miles below it, there's one more way to picture what actually failed. And I think it's the simplest one, even after everything else we've walked through. It wasn't an on-off switch. Nothing about the geodynamo has an off position, not really. It's been running continuously since not long after the planet itself formed, and by every measure available, it never fully stopped, not even at the worst point of the Lachamp collapse. What happened is closer to a dimmer, one that got turned down hard and left sitting low for the better part of 1,000 years, before whatever internal churn had disturbed it finally settled back toward its usual brightness. The lights didn't go out. They just got dim enough for long enough that anyone standing underneath them, had they possessed the instruments to notice, would have known something in the wiring, far out of sight, had gone badly wrong. Which brings us back to that patch over the South Atlantic, the one satellites are dodging today. Operators of low-orbit spacecraft treat it the way a driver treats a known stretch of bad road. Not a reason to stop driving, but a stretch you slow down for, a stretch where you brace for something you can't see happening under the surface. Instruments get cycled into safer modes. Engineers plan mission timelines around it. It's a strange thing to realize. Right now, today, there are machines in orbit above you that are actively, deliberately, steering around a weak patch in the exact same shield that failed across the entire planet 41,000 years ago. Not because anyone thinks a new Lachamp is imminent, nobody credible claims that, but because the same restless, unfinished engine that produced that ancient 1,000-year failure is still down there, still running, still capable of producing weak patches, growing patches, patches. A satellite can actually measure getting worse over the span of a single decade. Take a breath. Feel it move through you, into your chest, into your blood, ordinary, automatic, the same breath you've taken without thinking 100,000 times today alone. Nothing about it feels historic. Nothing about it feels fragile. That's the trick of it. That's the trick of all of it. The ground, the sky, the small, silent machines spinning 2,000 miles beneath your feet, keeping faith with you so completely that you never once had to ask it to. Somewhere in a swamp in New Zealand, a tree that's been dead for tens of thousands of years is still, in its own quiet way, keeping watch over a version of this story none of us were alive to see firsthand. It didn't know it was witnessing anything. It just grew, one ring at a time, faithfully recording a sky that had gone strange above it for 1,000 years, with no one there to explain what was happening or why. And then the sky came back. The needle found north again. The world, whatever it went through, kept going, carrying, eventually, all the way down to you. I don't know if it was a catastrophe or a close call science has learned to live with. Nobody does yet, honestly. But I know the shield came down once, and I know it's still moving now, measured in real time by machines in orbit above your head as you sit here. So take a breath again. Let it be ordinary. Let it be enough for tonight that the sky is holding.